Okay, this is standard 37 from Mr. Yin's class. Thought I'd spray paint it on the wall here. Standard 37. And one of the questions that is asked is, what is the inverse operation of raising a term to the second power? Taking the root. That's the answer to that. What is the inverse operation of raising a term to the second power, which may show up on the test? Taking the square root. That means you have x equals the square root of 121. You take it to the power 2 on both sides, and then you solve. What makes a radical expression? It's another question that he asked. Mr. Yin asked. It has to be a root, just like that. That shows you that it's a root. It could be third root, fourth root, fifth root. And also variable must be inside of it. So there's your variable. So what makes a radical expression? It has to be a root. The variable must be inside of it. It has to be a root. Variable must be inside of it. The inverse operation of raising a term to the second power is taking the square root of it. So you put it to the second power on each side of the equal sign. And I think that's the definition of standard 37. If we're looking for a definition of standard 37, is that this is what we're going to practice today. It's taking the second power, and putting this to the second power as a way of getting rid of the square root. Because once you do that, that sign right here goes away. Okay, and then it makes it easier to solve.
Just like in our warm-up, for problem number 3, let's use that hypothesis. Let's go ahead and recognize that everything is already isolated. The radicals have nothing around them. Let's go ahead and square it. For the first one, I'm going to scratch things out so it's very easy to see. It's very easy to see what's going on. Yep, we're about to get there. So I end up with x plus 3 equals 2. Subtract 3, subtract 3. Dorian, let us know our final answer, please.
It might not be x.
X equals -1. For the box around it, you're done. We're going to do the second problem as well at a pretty brisk pace. If you have any questions, if you can hold off until we finish the second problem, anything you need me to rephrase as well. Alright. Let's do what Ethan pointed out earlier. We're going to go ahead and square it like before. So you end up with 3x, and this time I will not use the red marker, because we know what's going to happen. You end up with something like this. Yep, we're about to do that. Can you say that out loud? So Darren said add 1 to both sides. So you end up with 3x equals 2x plus 1. I'm going to use the red marker just to scratch out the 1s. Next step that we have, Blue. Alright, next up, let's go ahead and bring the 2x over as well. So once we bring the 2x over, we should have minus 2x, minus 2x. And just FYI, if you did minus 3x, and you did this problem a different way, but you still follow all the legal operations in math, you should still end up getting the same answer. You should end up getting x equals, let's scratch this out, 1. So there's more than one way to get the answer in this case. I'm just doing one way up on the board. You end up getting x equals 1.
Okay.
Yeah. A lot of times.
I'll do this job.
And and once you copy this down, what's the first thing that we should be doing? Not literally, but what's the first thing that we should start thinking about? Just to build up a good habit.
Alright.
Here.
It really wasn't.
So I would look at this and not only start thinking about how to solve it, but asking yourself always, why did this again separate this from the first problem set? What is this? How is it different? Got it. So now you have, basically you have division inside the square root. Right? So, or you can think about it like, oh, now I have the left side, the right side more complicated. And you should start asking yourself, how do I take care of the divide by 5?
Oh, I know.
Let's see. I just want to pose one more thing. Class, I want to give everyone choice. So for my last class, I gave everyone 2 methods. And I noticed that everyone liked method number 2. So should I even show you method number 1? Or should we go straight to method number 2?
Number 2.
What do we think over there? Number 2, over here, gentlemen?
Number 2.
Okay, if we just go ahead and do method number 2, you do not have to worry about box number 3. So box number 3, when we took those notes, we won't be referring back to those. Don't worry about box number 3 then, if we're going to do method number 2. Table in the front. I need y'all with me, okay? Let's go ahead and square this, because we know.
Volume 2.
Alright, we're going to go ahead and square it. I think this is the stuff that we already know what to do, so I'm just going to do it and put it on the board. But now that we're here, we're kind of at a junction. So the question is, do I bring the 2x over? Do I bring the 9 over? What do I do with the 5? Why is the 5 on the bottom? Christian says bring the 9 over. Anthony, what would you like to do? Let me go ahead, let's just, that is perfectly valid. If we did method number 1, you would think about it as 1/5 of x. But since we're sticking with method number 2, we're going to forget about that box, and we're just going to think about it as x divided by 5. If, when it comes to solving equations, I were to give you 3 pieces of advice for the whole year about algebra 2, this would be one of them. Whenever you try to solve for x, and you have division, the division will always be there to bother you. You have to get rid of division. Don't have to. The best thing to do is get rid of the division early on, because the division is constantly going to be in your face. So the way to get rid of division is, let's hear that out loud. Let's hear a shout out for that. How we get rid of division. So before you do anything else, you think to yourself, wow, that division is really a pain in the butt. I'm going to go ahead and get rid of it by multiplication. If I do multiplication on one side, I need to do it on the other side. So I'm going to go ahead and leave 10x plus 45 because we went ahead and distributed equals, if the 5 and the divide by 5 cancel out, you should end up with equals x. Let's go ahead and choose your own adventure right now. How do we want to do this? Bring the x over or bring the 10x over?
Bring the x over.
Sure. 9x plus 45 equals 0. And then let's go ahead and bring that 45 over. You get 9x equals negative 45. I'm not even going to write the final answer on the board. Can someone, in about 10 seconds, let's see hands up so I can get the final answer for this problem. Alright, let's get 10
I
seconds.
draw a light is negative 5.
Alright, hands up if you got it.
I got it.
Well, I don't want to hear voices. I said
Hey,
hands
I'm
up.
chill. I'm answering too many questions. Oh, shit.
Oh, Dorian, go ahead.
Oh, what?
Give us the final answer. It's on the board for last step.
I didn't know. Alright, ain't it? You should take 5, 9 from both sides, right?
Subtract.
Hey, I don't know.
Bro,
We got multiplication right there. Divide. So what do you get once you divide negative 45 divided by 9?
yo.
It's 5.
Negative 5. So say the whole thing. X equals.
X is a -5.
Well done.
You put
That's your answer to the first one.
They show me.